Stop wasting money on junk car products. Seriously. Some of these so-called performance upgrades can actually hurt your engine. In this video, we're cutting through the hype so you can keep your cash and your motor healthy. You'll learn what to avoid, what to buy instead, and why the engineering never matched the marketing. I see the same mistakes roll into the shop week after week, and today I'm breaking down the 5 biggest money wasters that do more harm than good. Let's dive in. Here's the key. We evaluate how these products work in the real world, not just on packaging claims. We look at mechanism of action. What does it actually do to airflow, fluid flow, sensors, and combustion, and where it introduces risk? The criteria are simple. Performance impact you can feel and measure, longevity over thousands of miles, cost per mile, and system compatibility with modern fuel-injected engines. We prioritize evidence in this order. OEM guidance, known engineering principles, shop outcomes, then marketing. Scope-wise, this applies to daily drivers and lightly modded cars with MAF sensors and modern ECUs. We're not talking about wild builds or carb setups. Limitations? We're focusing on product categories, not calling out specific brands, and we won't pretend edge cases are the rule. If it promises power without addressing air, fuel, or tune in a coherent way, we're skeptical by default. That mindset protects your wallet and your engine. Throttle body spacers. Throttle body spacers get sold as cheap bolt-on horsepower. The story is, more plenum volume or air swirl equals better atomization and throttle response. Sounds neat, but on modern multi-point or direct-injected engines, that theory falls apart. Your intake runners are already tuned for velocity and resonance at specific RPM ranges. Adding a spacer changes the geometry right at the throttle plate, often creating turbulence where you want smooth, laminar flow. In real-world use, that turbulence doesn't help. Fuel injects near the valve on port injection engines, so swirl upstream doesn't improve mixture quality at the cylinder. On direct injection, fuel goes straight into the chamber. Air swirls in the intake don't touch atomization. I've seen cars with spacers show no repeatable gains on a dyno and no change you can feel from the driver's seat. Throttle response stays the same because your ECU is already managing airflow and throttle mapping aggressively. Compared to OEM design, the intake manifold is a tuned instrument. Think of it like an exhaust header in reverse. Runner length and cross-section set the torque curve. A spacer is like slipping a random adapter between pipes. Now you've got a mismatch, potential flow separation, and disrupted pressure waves. The result? Best case, nothing changes. Worst case, you lose a bit of low-end torque where runner velocity matters. Now the risks. You're introducing another gasket surface that can leak. A small vacuum leak can trigger a rough idle lean codes and long-term trim drift. On some platforms, the spacer changes the angle of the throttle body or sensor relationship just enough to cause idle instability or a CL. You'll chase ghosts thinking it's a dirty throttle or bad O2 when it's the spacer causing a subtle air leak. I wanted to love the idea for a cheap win, but test after test, the needle doesn't move. No repeatable horsepower. No consistent improvement in throttle feel. And any tiny change you think you feel is often placebo or just ECU adaptation. Value matters. You drop cash on a chunk of aluminum, spend time installing it, and end up with zero net performance. That money is better spent on tires and alignment, a proper tune matched to your platform, or catching up on maintenance like plugs, filters, and fluids. Those give real gains you can feel: shorter stopping distance, better cornering, smoother power. If you're running a carb or throttle body injection from the old school, a spacer can change mixture path and sometimes help with distribution. But for modern engines with multi-point injection, or DI, it's a dead end. The deal breaker for me is simple. It doesn't improve airflow where it matters, and it adds failure points. Skip throttle body spacers on modern engines. If you only care about sound and looks under the hood, fine, but don't expect power. If you want actual performance, focus on a well-designed intake system, a heat-soaked resistant air path, and ECU calibration that optimizes timing and fueling. That's where the wins are, and that's where your money should go. Airflow myths are one thing, but liquid band-aids can do real damage. The next product can quietly choke your heater core and radiator, turning a small leak into a big bill. Radiator stop leak. Stop leak promises a no-wrench fix for coolant leaks. The bottle says pour it in, drive, and the leak seals itself. The thing is, your cooling system relies on controlled flow through narrow passages. Anything that adds particles or reactive goop risks clogging the smallest tubes first, usually the heater core and the fine passages in the radiator. Here's how it bites you. Most stop leaks use fibers, particulates, or reactive chemicals that coagulate where temperature differentials and small gaps exist. That sounds like targeting a leak, but the same conditions exist inside the heater core's tiny tubes and at the radiator's microfins. You get deposits that reduce cross-sectional area, flow slows, coolant spends longer in hot zones, and temps creep up at highway load or long hill climbs. Symptoms build slowly. You'll notice weak cabin heat in winter even though engine temp looks normal at first. Then the gauge starts hovering a needle width higher in traffic. Fans run more often. You might hear the water pump start to whine as it works harder to push restricted coolant. Thermostat housings can collect residue, making the thermostat sticky. Too slow to open, too slow to close, so temperature control gets sloppy. Compared to a proper repair, stop leak is a short-term bandage that can turn a pinhole into a system-wide restriction. I've seen cars that sealed a drip, but came back months later needing a heater core, radiator, and a full flush. And flushing is no picnic. Once these compounds plate the tubes, you're not getting all of it out with a garden variety flush. Residue lingers and keeps degrading heat exchange. Let's talk real fixes. Pressure test the system to confirm where the leak is. Use UV dye if needed to trace a slow seep. Replace the failed part. Hoses harden and crack, plastic end tanks split, caps lose pressure control, and water pumps weep at the seal. When you repair, fill with the correct coolant type and concentration for your platform. That chemistry matters for corrosion control and water pump lubrication. Are there edge cases? On a trail, in the middle of nowhere, a stop leak can buy you miles to limp home. If you do that, the plan should be 1. Get home, 2. Schedule a proper repair, 3. Perform a thorough flush, and 4. Replace any component that lost flow, often the heater core or radiator, because partial clogs are future failures waiting to happen. Do the cost math. A cheap bottle versus the labor to pull a heater core sounds tempting, but it's a false economy if the bottle causes that heater core to fail. The radiator and water pump aren't cheap either, and overheating once can cook head gaskets, warp heads, and ruin your week. Avoid radiator stop leak for daily drivers. It's not maintenance, it's a gamble that trades a small, fixable leak for long-term cooling system damage. Pressure test, locate, and repair the source. Use the right coolant. Restore flow and you'll restore reliability. We handled the cooling loop, now let's address the intake. The next performance drop-in filter can foul your MF and quietly rob power instead of adding it. Oiled performance, drop-in air filters. These get sold as a reusable upgrade. Better flow, better sound, save money by cleaning and re-oiling instead of replacing. On paper, that sounds efficient. In real-world use on MAF-based cars, the oil is the problem. The MAF sensor sits right after the airbox and reads airflow with a heated film or wire. If oil mist gets on that element, it insulates it. The ECU sees the wrong airflow, trims swing, and drivability suffers. Why buyers care? You want smooth throttle, consistent power, and solid MPG. The filter is the front door to that system. The claim is more airflow equals more power. But on a stock or lightly modded engine, the OEM airbox and paper filter already flow enough for the demand curve. The bottleneck isn't the filter, it's often the intake snorkel diameter, the throttle body, or the tune. So the risk from oil contamination outweighs the supposed gain. In real-world use, over-oiling during maintenance is the usual culprit. You clean the filter, apply oil, and even a light excess pools along the ribs. Under high airflow, that oil migrates. It doesn't take much. The MAF's thin coating turns sticky, dust adheres, and readings drift. You start seeing rough idle on hot restarts, a slight hesitation on tip-in, or a lazy power delivery in the mid-range. Sometimes you'll get a sale for fuel trim out of range or MAF performance. Clear it, and it returns because the sensor is still dirty. Compared to the OEM paper element, a fresh quality paper filter flows plenty for stock plus setups. I've seen back-to-back pulls where the drop-in oiled filter showed no repeatable power increase and sometimes a tiny loss if the ECU started trimming rich. The ECU's corrections mask what little airflow change exists at part throttle. At wide open throttle, the factory box is usually adequate until you move serious air with cams, boost, or a reworked intake tract. Here's the simple analogy. The MAF is your engine's glasses. An oiled filter is like smearing those glasses with a thin film. You can still see, but everything's off. The ECU compensates, then hits limits, and the experience degrades. Clean the glasses, and suddenly the world is sharp again. Symptoms you'll notice: idle hunts, throttle feels gummy, MPG dips a bit, and the exhaust smell changes at startup. You might chase coils or plugs, but data logs reveal unstable MAF GES and long-term trims drifting. Clean the MAF with the right electronics safe cleaner, never touch the element, and replace the filter with a dry unit or a fresh OEM paper. Often, the car immediately feels calmer. Value assessment. Reusable sounds thrifty, but the cleaning kit, drying time, and risk of over-oiling add hassle. Cost per mile, a quality paper filter replaced on schedule wins for most daily drivers. If you want a performance option, choose a high-quality dry filter that maintains good filtration. That keeps the MAF happy and the trim stable. Verdict: skip oiled drop-ins on MAF cars. Go dry or OEM. If you're heavily modified and truly airflow limited, step up to a well-engineered intake system that relocates or shields the MAF properly and tune for it. Otherwise, keep it simple, keep it clean, and your engine will reward you with consistent power. High performance. Spark plugs, wrong spec. Spark plugs are marketed like magic. Exotic metals, special straps, multiple electrodes, bigger spark. The thing is, your ignition system is a matched set. The ECU, coils, dwell strategy, plug heat range, and gap all work together. If you drop in a plug with the wrong heat range or an out-of-spec gap, you're asking for misfires under load and inconsistent combustion. Context first. Heat range is about how fast the plug transfers heat to the head. Too hot, and the tip stays glowing, which can cause pre-ignition. Too cold, and the tip never cleans off, leading to fouling. Modern engines are calibrated around a specific range and projected tip. Deviate without a tune, and you shift the safety margins. In real-world use, the wrong plug shows up as a stumble climbing a grade, a hiccup merging onto the highway, or a random idle shake with no clear code at first. Under boost or heavy throttle, the ECU sees misfire counts and starts pulling timing to protect the engine. Power drops, exhaust temps can rise, and raw fuel may reach the catalytic converters. That overheats the CAT substrate and shortens its life. You thought you were adding performance. You just added stress. Gap matters too. A larger gap can improve burn speed if the ignition system can support the voltage. But if your coils aren't designed for it, they work harder, inconsistently, and you get blowout at high RPM. A smaller gap may mask a weak coil short term, but can reduce flame kernel development and efficiency. The right gap is the one the manufacturer specified for your platform and tune. Compared to OEM spec Iridium or Platinum, those plugs are designed for stable spark, long life, and compatibility with coil dwell strategies. They resist erosion, hold gap longer, and maintain consistent ignitability across temperature swings. If you want performance, the real secret is a tune that optimizes fuel and timing for your fuel quality and setup. Then, if the tuner specifies a different heat range or gap, follow that data-led spec. Maintenance details matter. Always verify gap even if the plug is pre-gapped. Manufacturing tolerances and shipping can tweak it. Use a torque wrench. Over-tighten, and you risk stripping threads or distorting the crush washer. Under-tighten, and you risk poor heat transfer and loosening. Apply dielectric grease at the coil boot if required by your service manual to prevent arcing and moisture intrusion. Replace on schedule. Waiting too long can seize threads, break insulators, and turn a simple job into a nightmare. Value assessment. Chasing more spark is a distraction. Consistent spark wins. OEM equivalent Iridium Platinum gives you stable combustion, better MPG, and fewer misfire headaches. If you're tuned or boosted, work with your tuner on heat range and gap. Data logs and plug reads tell the truth. Marketing copy doesn't. Verdict: run OEM equivalent plugs unless you have a proper tune and a reason to change spec. Reliability beats hype. You'll keep timing where it belongs, protect your cats, and get the smooth power you can feel every day. Not internal, but it hits your wallet and safety next. Those bargain headlight kits look great today, then fade fast and leave you with hazy lenses a few months later. Cheap headlight restoration kits. Those wipe and shine kits feel like a win, but they skip the UV hardcoat. You sand and polish, lenses look clear, then the sun cooks the raw polycarbonate and oxidation rushes back. Night visibility drops, scatter increases, and you're redoing it in months. The right process is staged sanding, polish, then a durable UV sealer. Ideally a 2K clear. Spend once, see better, stay safer. Put money into tires, alignment, quality fluids, reputable pads/rotors, an OBD2 scanner, and on-time maintenance judged by cost per mile, not sticker hype. Parts that extend intervals or protect systems pay you back. Shortcuts add risk costs that dwarf the deal. If it claims power without addressing air, fuel, or tune, be skeptical. Fund maintenance first, then targeted upgrades that your platform can use. Daily drivers with modern ECUs, MAF systems, light mods, emissions-compliant builds. Skip if you're carbed or fully track-tuned. Match parts to goals. Skip these 5 products and put your money into maintenance and parts that actually preserve power and reliability. Airflow gimmicks, liquid stopgaps, oiled filters, wrong spec plugs, and bare polish headlight kits cost you more over time and can hurt performance, cooling, and safety. The rule is simple. If it doesn't align with proper air, fuel, spark, and heat management backed by data, don't buy it. Subscribe for tested guidance that respects your wallet and your engine. Hit like if you value clean, reliable power.